I'm a big exceptions hater. They are slow and they mess with control flow in very weird ways. Let's say we have a function, let's call it foo. And let's say this function returns something like foo result. And then let's say we have a function bar. And bar will just call foo and return its result. Right, and let's make it const. And then we have another function buzz that will call bar. So let's actually not return result here. Let's console log it. For result is result, something like this. And buzz will just call bar, right? And our top level script will call buzz. And if we run this function, we get foo result is foo result. So far, so good. This is a normal program flow as any reasonable person would expect. You call a function, it calls a function, it calls a function, then that function returns, the stack pops once, twice, thrice, we get back. Regular, normal control flow, no questions about that. Now, what happens if foo throws an exception? So let's throw an error here, foo error. And then we run our script again. And this doesn't tell us much. Let's add few console logs. So for example, console.log buzz start. And at the end, we're gonna have buzz end. And here we're gonna have bar start. And at the end, we're gonna have bar end. And same with foo. So foo start, foo end. Something like this. Let's run it again. And here we see that we are entering buzz, we enter in bar, we enter in foo, so this one, so far so good. But then we get thrown an error and our program just straight up terminates. So of course now we need to handle this exception with a separate language construct. So we need to wrap our bar into try catch block. So catch error, and we do something like console log error thrown from bar. We don't know exactly where. It could be thrown from bar itself, from foo, from something that foo calls. We don't know. And now if we run our program, we see that buzz start, bar start, foo start. So we go all the way here. Then we get an error thrown from bar caught here, and then our buzz gracefully ends. So our normal expectation of a straightforward control flow is completely subverted. Now we cannot rely on the fact that control flow goes up and then down. Now we need to be aware of the fact that it can jump through functions all over the place. And there is of course an argument in favor of it, right? So, oh, what if this is a database error and we need to return entity not found to the user? Now, bar does not have to handle this error. It can just work with the green path, and since exception gets caught in buzz, buzz can just act as a central hub for returning user errors. Isn't that convenient? And if you ever shipped anything to production and had to debug stuff, you know how big of a lie it is, right? Hopefully I don't have to convince you. It's just so hard to debug all of these exception issues. On top of that, very few programming languages with exceptions even help you to determine whether a function can throw one or not potentially. So this is a JavaScript. I mean, JavaScript doesn't really have types, right? But even TypeScript, the typed version of JavaScript that pretty much everyone uses now, it doesn't really have a way to indicate if something throws an exception, to the point where now a lot of people adopt an entirely different paradigm of writing TypeScript, which is called effect. Not sponsored, by the way. Effect basically adopts this result type that you might know from Rust programming language, where you wrap everything into result and then you need to unwrap it, so kind of a mandatory error checking. And you can see that maximum type safety, including error handling, is literally their first marketing point. This is how bad the situation is. And if you scroll a little bit down below, the very first code snippet shows you how you get rid of a nasty nested exceptions handling with this nice like 6 lines of piping something into something. And there is a thing in Java which is called throwing checked exceptions. And if you do that, you must write like throws like foo error or something like that. And then at least a consumer of your function knows that, okay, the foo can throw that, then you must somehow catch it. And so I feel like modern programming languages, without all this legacy baggage, they move away from exceptions, right? So Rust doesn't have them. Of course, Jai doesn't have them. Zig doesn't have them, and Odin doesn't have them. So yeah, it seems like exceptions kind of go out of fashion, and I am very big fan of this. I am in favor of it. And the reason actually why I picked JavaScript for this demo is because JavaScript exceptions are kind of crazy. So let's drop into Node console here, and you can throw a normal error, right? So error, I don't know, like foo. So you can throw a normal error. It says uncaught error foo, but you can also throw a number. You can throw a string. You can throw null. And in JavaScript, you can throw literally everything. And there were people who look at this and instead of thinking that this is very sus, nobody should ever use it, they decided to abuse it. So one of the things you can throw in JavaScript is a promise. So new promise, and you need to give it a resolve function. So yeah, you can throw a promise as well. And if you never programmed in JavaScript, you can think of a promise as of an asynchronous callback that will be executed sometime. And so let's say we have a couple global variables. So one of them is gonna be p, we're gonna assign a promise to it, and another one is gonna be some kind of a flag that will check if promise is already finished. So yeah, like this. And then in our function foo, we actually assign p to a new promise. And this promise will have its own resolve function. So resolve function takes a callback that you call when the function is resolved. And the, and inside of this promise, we'll actually gonna set a timeout. So set timeout. In JavaScript, set timeout kind of just sets a callback and then executes it in a set number of seconds, or rather milliseconds. So, and this set timeout also accepts a callback because of course in JavaScript everything accepts callback. So let's give it a 3 second of a timeout and let's console log something. So for example, full loaded. Let's say it's a network request that takes 3 seconds to fulfill. After this, we set loaded to true. And after that, we call resolve. So whoever takes this promise knows that it resolves. But we don't just call resolve, we can actually pass anything to it. And let's pass a reference to ourselves. So to foo function. You can do this in JavaScript. And at the end here, what you're gonna do is you can do something like if not loaded yet. You can say console log foo is not loaded yet, right? And you can throw promise. You can throw this promise. Yes, and at the end, let's replace this return with something like foo ended, right? So yeah, and here if p equals to null, we're gonna create this promise. Otherwise, we're just gonna check if it's loaded. So hopefully you see what's going on here. We enter in the foo, we see if the p promise is not created yet. So for example, if request is not initialized yet, we initializing and starting some remote request to fetch something over the network. And then we check if it's not loaded yet, then we throw the promise. Now our bar does the same thing as it did. Without this, we don't need that anymore. And then buzz in try and catch block, it will try to catch an error. Well, let's rename this to promise, so it's less confusing. And we're gonna log something like promise is not ready, and then literally then, so p.then is you attach something to the promise that executes when it is successfully fulfilled. This is just what you do in JavaScript. And here in this body of an internal callback, you accept whatever parameter the promise was resolved with. So in this case, the promise gets resolved with foo. So let's call it callback, right? And then what you can do is you can call it. And let's look a little bit. So restarting the callback. And so you see what I'm doing here. We start buzz starts bar starts foo. Foo initializes some kind of a remote request and then throws the promise that gets caught here in buzz. And when the promise is fulfilled, we call this foo straight from buzz, avoiding bar, and let this last part of foo to finish. Do you see what's going on here? So this pattern lets you restart a function that got suspended on a promise that is yet to be fulfilled. And so if I did everything correctly and we just call main.js, so promise is not ready yet, bar buzz end, because yeah, we got here, and then foo loaded. So we got here at the end. You see, and console is not a function. Where it is? Oh yeah, it's console log, of course. Yeah, so let's run it again. So we are waiting. So we got here and we are waiting on this callback to restart. And then you can see foo started again and foo end because it is now loaded. So there you go. And you would think, who abuses such a thing? And my answer to you is the most used and popular web library in the entire world. It's called React.js and it has this thing called suspense. So React has this somewhat a mix of HTML and JavaScript, and basically some component is a function that executes something inside, and something inside of it that is suspense enabled will throw a promise, and then React will catch this promise on a suspense boundary. This is how they call it, and then it will render whatever you pass in a callback. And so this pattern is used to display your loading indicator. So if we scroll down here for the example, you can see that we have an artist page that returns you a header, and then the suspense thinks that inside of it renders albums for an artist with a certain ID. And then we click, we get this loading spinner, and then eventually albums load. And so here is our loading component that displays loading, and it is passed as a fallback to a suspense. And they tell you that in order for this to work, you need to use a fetching framework that supports this whole machinery. And one of the most used frameworks that has this enabled is called TanStack React Query. You can see it has almost 50k stars. And in its code, deep down in use base query, you can actually find here, you can find throw fetch optimistic. And inside of this fetch optimistic, I'm not gonna show you, just trust me, there is, well, a fetch call that fetches over the network. And if should suspend, it will just throw this promise that React will catch. And then render a fallback, so this kind of loading screen. And then when the promise finally fulfills, it will trigger a render of an entire tree and finally get you the albums. And React programmers love their spinners, and this is why every time you open a website, you see like 6 different spinners all over the place, individually loading every single part of the page at their own pace. And I will let you be the judge whether it's very cool or super horrifying. Thank you very much for watching, subscribe if you like what you see, and I will see you in the next video. Bye bye.